Hi folks, today we are diving into a fascinating integrated circuit from the first half of the 1980s. This chip has not just one but two main roles. First, it acts as an interface for a VFD display. Second, it can process and interpret an incoming frequency signal. The component we are looking at is the LC7258. Originally designed for frequency displays in FM, shortwave, medium wave, and long wave radios for both car and home use. It actually has two sibling chips. There is the LC7257, which drives red LEDs with a common cathode, and the LC7257P, which drives green LEDs, also with a common cathode. Our focus, however, is the LC7258, built specifically to drive fluorescent display tubes. Despite its age, this chip avoids a common source of confusion found in many CMOS LSC devices of that era, the naming of VSS and VDD pins. It was released by Sanyo and became a frequent presence in many 1980s tuners. Examples include models from Sansui such as the 5900Z, 4900Z, and 3900Z, as well as the KT900 from Kenwood. Physically, the chip comes in a deep package with 42 pins and a pin spacing of 2.54 mm. It operates with a VDD supply ranging from 7 volts up to a maximum of 10 volts. It is commonly paired with a frequency divider chip, M54459L. On this particular panel, we also find an MSM4016RS used for line switching, along with an SN74LS90N. A quick warning here: the power pins on the last chip are not in the usual positions for the SN74LS family, so always check the datasheet carefully. The original device this panel came from is unknown. Still, we brought it back to life to show that anyone lucky enough to own this integrated circuit can work with it quite easily. That said, there are a few small design flaws you need to watch out for, because they can lead to serious mistakes. First, there is an error in the silkscreen labeling on both the top and bottom sides for IC902 and IC903. Second, there is no protection resistor or capacitor on the base connection of the two SC930 transistor where it enters the printed circuit board. This can easily damage the transistor. In my case, I had to replace it with an S9018H and reposition the pinout. Third, the panel markings indicate plus 5 volts and plus 12 volts inputs. However, the LC7258 has a maximum VDD of only 10 volts. The only thing limiting it is a 330 ohm resistor in series with a 12 volt line. Fourth, the if FM selection pin, which sets plus 10.7 or minus 10.7 MHz and is located on pin 8, is tied directly to VDD with no protection resistor. That makes it impossible to use the alternative option without physically cutting the PCB trace. Given all these details, I would argue that using the LC7258 in standalone mode on a breadboard is actually easier. That way you are not restricted by the existing PCB connections. Now that we understand the chip a bit better, let's look at how it works. You will notice there are 3 pins for band switching: shortwave, medium wave, and FM. I am changing them manually on the breadboard, although using a proper switch would definitely be better. Since the band selection is manual, the input point also has to be changed individually. To confirm calibration, pin 12, which selects 5 or 4-digit mode, had to be isolated so I could apply plus 5 volts to it. That value corresponds to half of the 10-volt VDD supply being used. This puts the chip into calibration mode, where the digit in position 4 blinks at 10 Hz, while I inject an 80 MHz signal into the board with the FM intermediate frequency selected. Because pin 8 is tied directly to VDD, the reading must be 10.7 MHz above the tuning value of the frequency generator. If it were tied to the ground instead, it would be 10.7 MHz below. I only perform this calibration for the FM band, but it can also be done for the other 2 bands using their respective intermediate frequency values. As you can see, every time I switch bands, the megahertz or kilohertz indicator also changes. This is handled by the MSM4016, also known as the CD4016. When no signal is being injected, the display shows a default value offset according to the selected band. The medium waveband enters the PCB through the base of the 2 SC930 transistor, which acts as an RF amplifier. It is important to remember that all 3 bands reach this board only after the first amplification stage inside the tuner front end. Because of that, they should be carried by a coaxial cable to the panel. This makes it possible to convert almost any analog dial tuner into a digital frequency display. And that wraps up today's deep dive. If you enjoy exploring classic electronics like this, you are definitely in the right place.